Where did we come from? How did we get here? Our history in the cosmos and on planet Earth was shaped by countless events, some obviously epic, some seemingly trivial, yet all vital in getting us to this point, here and now, the people we are today. One of the reasons we're here, that we exist at all, is that Earth, cosmically speaking, is in a relatively peaceful place, orbiting our sun in a near-perfect circle. Our cosmic neighborhood has granted life billions of years to evolve, mostly undisturbed. But where did this stable piece of real estate come from? We know that stars and planets, once upon a time, all started out like this, with enormous clouds of gas and dust. How we got from here to here, we haven't exactly figured out yet. But lately, we've found some intriguing new evidence that tells us our peaceful solar system may have started with a violent event. If we want to unlock the secret behind the origin of our sun and its planets, it would be helpful to find some remnants from the birth itself. An event that took place about 4.5 billion years ago. Luckily, there are some rocks left over from our earliest days. Asteroids, formed during our solar system's birth. Occasionally, some of them drop in on Earth. And when they do, they're called meteorites. I've come to the deserts of Arizona to try to track down some rare space rocks. Where are we?
Perfect place for hunting for meteorites. Southern Arizona. Look at this. Couldn't ask for a better place. It's an open desert. It's an old lake bed. And so the sand is being blown away like right now, and it's exposing the rocks that are on the ground. And it's just so you're just looking for something that looks a little bit different. And you'll know it when you see it.
Well, I'm from the city, so all this looks different. I'll be hauling everything back for you. So how do you spot a meteorite? Well, sometimes the signs are hard to miss. Some leave deep impacts in Earth, like one that blasted Arizona's Barringer crater 50,000 years ago. But most leave less obvious traces. They can be as small as dice, reduced to a rocky cinder. Then, they have to be distinguished from Earth's rocks. One trait stands out in nearly all meteorites: metal. They've got it. So the best way to find a meteorite is to hear it first. No question about that one.
And we can pick that up this far out.
Ruben Garcia brought along some samples and showed me why a metal detector is the meteorite hunter's best friend.
It's what meteorite hunters call a halo. You don't have to swing over the meteorite.
Yeah.
You get in that halo area and you hear the sound going up.
You get in the zone.
We like that. This is very typical as meteorites go. This is called an ordinary chondrite, and about 82% of all meteorites that fall are going to be of that variety.
Chondrites are rocky meteorites that haven't melted completely. That's what we want to find.
There's more. We've actually got what we call meteorite canes, and this is
These are golf clubs. I know. This is a golf.
This is a golf club with a very strong, in this case, two very strong magnets attached. Go ahead and test it with the cane and see what you got.
Yes.
Music to my ear.
I have found a meteorite.
You certainly have.
I keep this one.
We found it.
Are you guys ready to find some meteorites?
Let's go find some.
Go do it.
Hunting for meteorites is like trying to find a pebble on miles of beach.
One of the graduate students has found something. Watch the cactus.
Oh, thank you.
It sounds really big.
Oh, there it is. Piece of farm equipment.
That is your first meteor wrong. Congratulations.
Meteor wrong.
Meteor wrong.
But I want a meteorite.
So So all we do is fan out now and just...
We just fan out.
And just...
This is a whole area here.
It could be anywhere.
It's got something.
This has no characteristics of a meteorite.
This meteorite hunting is a lot harder than it looks. And some days, you don't find any. So they told me this was the remains of a meteorite hunter that came out unprepared. This is one of those days. Don't tell them what you find out here. Luckily, over the years, hunters have turned up more than 30,000 specimens. The largest, at around 60 tons, landed in Africa 80,000 years ago. Some of the rarest are pieces of the moon, blasted here after impacts there. But one of the coolest things about meteorites is that most were formed 4.5 billion years ago, during the birth of our solar system. When, for reasons not yet known, a cloud of gas and dust transformed into a sun with circling planets. So can these space rocks tell us what triggered the event? Here at Arizona State's Center for Meteorite Studies, its director, Minnie Wadwa,
Come on in.
is trying to decipher our cosmic past.
Here you will gown up to go into the clean lab.
Protective clothing prevents contamination from foreign particles. Inside, Wadwa breaks down meteorites in search of their chemical birth certificate. After crushing and dissolving them in acid, she can identify the atoms and molecules inside. The results? This 4.5 billion-year-old meteorite is laced with a special kind of atom called nickel-60.
Nickel-60 is interesting for us because it is the decay product, the daughter of iron-60. And iron-60 is really what we're after.
Nickel-60 is created when another atom, iron-60, decays through radioactivity. That number 60 tells you how many protons and neutrons are in an atom's nucleus. So when this rock formed 4.5 billion years ago, it was originally infused with iron-60. And iron-60 is created in only one place, a supernova. A supernova is the violent, destructive explosion that marks the death of a massive star. So that means when these meteorites were forming from a gas cloud during the birth of our solar system, the gas cloud had been sprinkled with iron-60 from an exploding supernova.
We're interested in iron-60 because it may be injected by a supernova nearby.
Right before we were all born.
Right before the solar system was born.
But wait a minute. A supernova is one of the most powerful explosions in the universe. It's so luminous, it can be seen across billions of light years. It releases as much energy in an instant as our sun will produce over its 10 billion year lifetime. So how could a baby solar system survive such a violent, destructive event? Well, turns out some researchers think the reason we survived is that the supernova explosion was actually the trigger that created our solar system in the first place.
The one question that we're trying to understand right now is, could such a supernova actually have been involved in the formation of our own solar system?
Alan Boss is one astrophysicist convinced that we owe our existence to a supernova. He thinks it happened like this. Like everything else in the universe, we started out as a cloud of gas and dust. Then, a distant massive star died and went supernova, sending a shockwave toward us. When the wave of pressure hit the cloud, it collapsed and condensed, starting a chain of events that led to the formation of our sun. You can think of it kind of like a snowplow. You can create mounds of snow or destroy them.
We can do either or.
So you are the supernova of the ski slope.
That's for sure. As
the plow pushes through a parking lot of light, fluffy snow, the snow clumps together in bigger and bigger chunks. Out in space, pressure hitting a gas cloud has a similar effect. Except, instead of snowballs, you get stars. Once you've got the makings of a star, gravity draws leftover gas and dust into a giant swirling disk. The dust continues to stick together, clumping into rocky asteroids, which eventually become orbiting rocky planets. And voila, a solar system. So is this where we came from? Well, not everybody's buying the supernova as a creator theory.
What remains a little bit controversial about that idea is that you can't have that fluffy cloud near the supernova. When that shock wave is just coming out of the supernova explosion, it's super strong.
For Steve Desch, a supernova hitting a gas cloud is more likely to do this. Like a snowplow in overdrive, a supernova shockwave might sweep away any gas clouds in its path. Desch thinks something gentler triggered the collapse. A shock driven by radiation from a massive star. But Alan Boss has crunched the numbers and insists that at the right distance, a supernova shockwave would be transformed from a destroyer into a creator.
We believe that our own solar system was a cloud sitting there in space, more or less minding its own business, when a supernova shockwave struck the cloud and have it collapse down and form a new star system.
We still don't know for sure what the trigger was. But since we've discovered meteorites with supernova dust, we do know that a violent explosion rocked our cosmic neighborhood at the time of our birth. And it's quite possible that without it, our stable, stately solar system would never exist at all.